Hi friends, as promised, I have come up with yet another video on your Unit 2 of Construction Engineering and Management. So yesterday I had uploaded video on Unit 1 of Construction Engineering and Management, and I'm happy that most of you have gone through the video. And just a kind reminder for all those who have not gone through it, please make sure that you go through the first video, that is about the Unit 1 of Construction Engineering and Management. And I request you all to please subscribe to this channel, do like, and also I'm open to any kind of comments, okay? Because your comments will help me in delivering proper videos and videos with the right content and something suited to your needs, okay? So I'm yearning for your feedback, okay? And please do subscribe and also share this channel with all those friends who are in need of these videos, which can help them to learn this subject. Okay, so coming to today's topics now. Okay, let us have a look at the syllabus. So Unit 2 is comprising of construction management through network theory. So we have definitions and different types of events, activity, dummy, network rules, network event numbering. Okay, just give me a moment. Let me share the screen with you all so that you can understand better. Okay, so here this one is the syllabus. Okay, you can see here we will be dealing with definitions and different types of event, activity, dummy, network rules, network event numbering. That's about Fulkerson's rule, hierarchies of complex network, work breakdown structure, linear scheduling methods comprising of bar charts, milestone charts, LOB, there's line of balance, the limitations, differences between PERT and CPM, network-based scheduling techniques, PERT, CPM, AON, and AOA in construction management, and the numerical problems. Okay, so I have dealt with all the topics in the class. Now we will just try to revise them. Okay, so all the notes which I had given are from the textbook Construction Planning and Management by P.S. Gehlot and B.M. Dheer. And as I've always told you, please, you should have got that book issued, or you could have also bought that book because it costs just around 250. But the value of content which the book delivers is simply priceless. Okay, it can help you for the remaining part of your engineering journey. So let us have a look at the notes which I had dictated in the class. Okay, so this is about the Unit 2. And first we dealt with some of the definitions, basic definitions. We defined event as a particular instantaneous point in time which marks the beginning or end of the activity. Okay, so simply event is marking the time. Okay, it doesn't consume any resources, it doesn't consume any time by itself. Okay, so which I had given an example in the class, like you're beginning an event. Okay, you're starting an event, or the event is getting completed. So marking of those times are is known as event. Okay, the event by itself doesn't consume any any duration. Okay, now activity is defined as a performance of any kind of task, operation, or job. Okay, now this is related to the construction industry, and any activity would consume time, resources, and it has a definite beginning and end. Okay, so we, for example, we have these different activities in construction management. Like we have this excavation of foundation, brickwork, laying, plastering of the wall, okay, backfill of the site or site excavation, okay, fixed shuttering, reinforcement works, etc. All these are activities which consume time and resources. Now we also have another term known as network. Okay, a network is simply a diagrammatic representation of a work plan which shows all the activities step by step leading to the established goal. Okay, and it also shows the interdependence or relationship between the various activities, and it also tells us which activities we need to do together and which activities must precede or succeed any other activity. Okay, so simply put forward, network is, it's a diagram which shows the relationship between all the different activities. Okay, and how all these activities, when they are carried out systematically lead to the established goal of the construction of that particular project. Okay. Now, network is represented in two forms, okay, namely activity on arrow and activity on node. Okay. Please make sure that you are learning these both the methods, okay, both the representations, because I do expect that you may get a question in the short answer type. Okay. So activity on arrow system. Now here actually the activity is graphically represented by an arrow, okay, which is drawn from left to right. Okay, and then you see the description of the activity is written above the arrow, as you can see over here. Okay, it is shown above, and also the length of the arrow doesn't bear any relationship to the duration of the activity. Okay, and also another point to be noted is the duration of the activity is written below the arrow, as you can see 4 days over here. Okay, now the length is in no way proportional to the duration that it takes. Okay, then this is about the activity on arrow system. Okay, then you can also see the example over here. Okay, we have these A, B, C, and D events. Okay, and how they are represented in the form of a network diagram. Okay, so this is basically the activity on arrow method. The second system of network representation is known as activity on node system. Okay, so here the activities are represented inside nodes. You can see the circular oval figures, which are nothing but the nodes. Okay, and you can see the dependence between each of these activities and nodes, which are shown by the arrows. Okay, and the time taken for the completion of any activities is indicated inside the nodes. For example, now this A3 represents activity A, okay, and 3 is the duration. So it could be either days or say days or months. So that unit will be specified generally. Okay, so that is about the activity on node system. Okay, so now there is moreover an event when it is graphically represented by number. Okay, that is an activity in node system. Okay, and the beginning of the activity is known as the tail event, and or also known as the preceding event. Okay, the head event is known as the succeeding event. Now we have certain network rules. Okay, when we are constructing a network diagram, we need to follow certain protocols, certain rules. Okay, now let us look at the rule one. Okay, now rule 1 states that no activity can commence until all preceding activities have been completed. So here, okay, we have an activity, for example, plaster wall. Now, obviously, it is, it can be understood by a common sense that plaster wall can always be carried out only after the construction of the wall. That is only after build wall is completed. So now you see here, this one, you can see the dependence between the different activities, and they are shown here. So you see here, plaster wall has been first build wall has got completed, and after build wall, the plaster wall is getting completed. Okay. Then moreover, another example, you can see that concrete foundation can commence only after procure cement, procure aggregate, and the installation of concrete mixer are all completed. Okay, we cannot go for a foundation concrete before these activities get completed. That is procurement of cement, procurement of aggregate, and the installation of concrete mixer. So this also shows the dependence between the different activities. Now that was the rule one. Okay. Now rule two states that when you have a dummy activity, okay, an activity which doesn't consume any resources, okay, and that activity is shown in the network to show the dependency to avoid duplicate numbering of activities. Okay, so this dummy activity is an artificial activity which doesn't consume any resources, that is, doesn't consume any time as well. And generally, it is represented by dotted lines in the network diagram. Okay, so you can see the dummy activity here from 2 to 3. This is trying to show the relationship or interdependence between the different activities, and no event can be left dangling. Okay, this 1 2 could have been left dangling if we had not introduced this dummy activity. Okay, so in this case here, erected beams can be taken up only when both concrete pier work and precast beam work have both been completed. Okay, now we go towards the rule 3. Okay, here rule 3 states that the logical placement of an activity in the network is governed by following three considerations. Now, what are those three considerations? First, we need to know which activities can be completed before a particular activity can commence, and that is known as the precedence. Okay, so for any given activity, okay, first we need to know which activity should be completed so that we can commence that particular activity. Okay, and that is known as precedence. Now second one, okay, which activities can be carried out along with this activity, and that is known as concurrence. Okay, then which activities cannot commence until this activity is completed, and that is known as subsequence. Okay, so that is also shown, with the help of a small example here. You can go through that example, right? And then you have rule 4, which states that no activity should lead back to the previous event. So you are having a kind of loop. Okay. Now you can see in this diagram that place concrete has been done and followed by cure concrete. Okay. And after cure concrete, the test concrete. Now this particular loop suggests that after the test concrete, then we are going ahead with place concrete. But place concrete has already been completed. Only after the placing of the concrete and curing of the concrete, we can go for the testing. But because of this particular diagram or this particular looping where an activity is leading back to a previous event, so this kind of anomaly should be avoided. So no activity should lead back to the previous event. Now you have this rule 5. In any network, we must have only one start and one finish. Okay, and any between any type of any number of activities in between, and no activity should be left dangling. And that's the reason why we are having this dummy activity, okay, which is shown by the dotted lines. So friends, just to make sure that you are learning about dummy activity, because this has come in the short answer type questions for a couple of times in the previous year's examination papers. So please make sure you learn about that. In fact, every topic is important, but like few things which are coming into my mind when I was going through the previous year's question papers. I'm just trying to and highlight those things so that you take special attention for those topics. Okay, so you have a question on network development, that is formulation of a network. Okay, so with regards to the problems of this kind, okay, I shall inshallah make a different video, okay, where we can focus completely. Otherwise then it becomes a very long video, and then you don't tend to go through it completely. Okay, another small request to you, when you are getting this video, please make sure that you are listening till the end and not trying to skip through some of the parts and not trying to bypass some of the clips here. Okay, please make sure that you remain with the video till the end so that you get the maximum benefit out of it. Okay. Right. So, after this example, we have this Fulkerson's rule for numbering the events. So when we are going for network diagram, okay, you need to be in a position to number the events. So the numbering of the events is governed by a rule known as Fulkerson's rule. So in any network, the event or nodes at the tail or head of the activity have to be numbered for proper identification. Okay, and that numbering should take place from left to right. Okay, which should show the logical sequence of activities. So please, guys, please make sure that you go through these 4 or 5 different steps, okay, which is very clearly explaining how the numbering of the events must be done. Okay, so here we go through this. We have in any network there's one initial event, and this initial event has arrows coming out of it and no arrows entering it. Okay, because this is the start of the event. Okay, start of the particular project. We are starting with one. Okay, and all the arrows are coming out of it and no arrow is entering it, so we number that event as one. Okay, after that we have all those arrows in step 2. We can notice that we have all arrows coming out of the initial event, and that gives rise to one or more initial events. Then we number the new initial events generated in step 2 as 2, 3, and so on. Okay, again we'll in the step 4 we neglect all the arrows coming out of these new initial events. Okay, then for that gives to further rise of other initial events, which are again numbered logically. Now this step is repeated till the last event when we have no arrow coming out of it. Okay, so this way we have tried to number the event, and this is an example, right? So that's the application of Fulkerson's rule. Please make sure that you're going through it. Okay. So with regards to network analysis, we have certain definitions. First, we have the earliest event time. Now, it is the earliest possible occurrence of the event, and that is earliest possible time when all activities leading to an event will be completed. It is denoted by TE and written above the event node. Okay. So now you see if you have this node 1, 2, 3, and 4. Okay. Now the late earliest event time, okay, T, which is denoted by TE, will be shown over here. Okay. It will be shown on top of the node, right? Basically, to the right hand side, you can see on top. Okay. So that is how generally it is done. And just give me a moment. Let me check if I can use some tools to highlight and show. Not able to do that. Okay, please bear with me. Now, after earliest event time, we have latest event time over here. Okay, and here it is defined as the latest possible occurrence of the event without delaying the project completion time. And that is the latest time when all activities leading to an event may be completed without delaying the project completion time. And that is denoted by TL. Okay, so you have two basic, very basic and very important terms. First is the earliest event time, and then you have the latest event time. And you need to know that earliest event time is represented by T suffix E, okay, this one over here. And latest event time is denoted by TL, okay, this one. So now we need to be knowing this forward pass in order to calculate the earliest event times, okay. So for example, now you can see this particular network, right? Here you have the event, the network starting from event one, okay, then two, three, four, and so on. So by default, when we are trying to calculate the TE by using the forward pass, that is moving in the forward direction, we assume that event one starts at 0 time. Okay, that's why we have written 0 over here. Okay, so the number which is written on top of the node is the earliest event time. Now, then we are actually adding the duration of the activity here. So this is the duration, 3 is the duration. So 0 plus 3 is 3. So then TE for node 2, earliest event time for node 2 is 3 days, okay, which we get by adding 0 and 3. Similarly, if I want to find out the earliest event time TE for node 4, then that would be 3 plus 4. Okay, the formula is Tj is equal to TEI plus TIJ. Okay, so you will come across the formulas in a short period of time. So we use the forward pass in order to calculate the earliest event times, and we are moving in the forward direction, that is from left to right. Now we have backward pass in order to calculate the latest event times, and in this case the computations would be made in backward direction. Okay, so we first find out the TL. Okay, when we are using the concept of forward pass in order to calculate the earliest event time, we stop at the node 5 as far as this example is concerned, right? So then we write TL as 9, okay, which is written at the bottom, which is same as TE, okay, TE for node 5. Then we move in the backward direction, so we can say that 9 minus 2 is equal to 7, and that's how you get the value of TL for node 4. Then I go for 7 minus 5 equal to 2, which I get, then thus I get the value of TL for node 3. So this is known as the backward pass. Okay. Then we have um, these calculations which you can see over here. Okay. Then we have certain definitions again, earliest start time and earliest finish time. So let us see how earliest start time is defined as. This is the earliest time when an activity commences since the starting point of the activity, that is the tail event. And earliest start time of an activity is TE of the tail event. Okay, simply put forward, now when you have an activity, when you have the tail event, when you have the head event, so the earliest event time of the tail event is known as the earliest start time. Okay, EST is equal to TEI. Then you have earliest finish time of an activity, which is nothing but it is the earliest time when an activity can be finished. And how are we mentioning the formula for that? Now you see here, earliest finish time can be denoted as EFT, and that is equal to earliest start time of activity plus duration of the activity. So EFT is equal to TEI plus TIJ. Guys, please make sure that you are remembering, memorizing all these formulae, because then if you don't know these formulae, you cannot attempt one of the long answer questions. Okay, everything is dependent on these formulas only. So then similarly, you can calculate EST of the activity 2, 4. So 2 is the tail event, 4 is the head event. So in this case, it will be TE of tail activity, that is TE of 2. Okay, so TE of 2 is 3 units, which we can see in the figure there. Okay, so similarly, you can calculate the remaining things also. Now, after earliest start time and earliest finish time, we have another definition, which is known as the latest finish time. So latest finish time here, it is the latest time when an activity may be finished, without delaying the completion time of the project. Okay, since finishing time of the activity is the head event, so latest finish time of the activity is same as TL of the head event. So this you can just see, check over here. Okay. Mm, we can just now, yes, finally I could get some tools over here. So this one, okay, you can see here, the latest finish time of the activity is same as TL of the head event. So make sure that you understand this. LFT is equal to TL of head event, known as TLJ. So J will be on top, L will be written at the bottom, friends. Just make sure about that. Okay. So now LFT is equal to tail of the head event, TLJ. Now latest start time of the activity. After latest finish time, we have latest start time. So latest start time is when an activity may be started without delaying the completion time of the project. Okay. So here, see, now I want to just to make sure that I can scroll it down. Okay, so yes, yeah, here we have. So TL latest finish time. So we have this latest finish time, which is same as TLJ, TL of the head event, and latest start time. It is the latest time when an activity may be started without delaying the completion time of the project. The LST formula is TLJ minus TIJ. Okay, now, now we have another very important definitions in terms of floats. Okay, float indicates the range within which the start and finish time of an activity may vary without affecting the completion time of the project. And float is related to activity times, and there are three common floats: total float, free float, and independent float. Okay, let us see one by one how these different kinds of floats are defined as. Now, total float is the maximum time by which an activity can be delayed without delaying the completion time of the project. So there is certain range, through which we can, delay the activities, and even by delaying by a certain time, the total completion time of the project doesn't get delayed. Okay, so that is the total float. Okay, total float is defined as latest finish time minus earliest finish time for an activity, which is same as latest start time minus earliest start time of an activity. Okay, so this is how we are, this is the formula LFT minus EFT or LST minus EST, and which is TLJ minus bracket TAI plus TIJ. Okay, this is very important. Then we have free float. Okay, another type of float. Here we are defining the free float as difference between EST of succeeding activity and EFT of the activity under consideration. Okay, and it is float available for activity without affecting the total float of succeeding activity, and it is based on assumption that all events occur at the earliest event time. Guys, you just need to put in some efforts to understand all these definitions. Okay, it may not always be possible to go for a detailed explanation over here, so I hope you can understand this. So for free float, now this is the particular sentence. Okay, and this is the formula: free float TEJ minus bracket TEI plus TIJ. Okay, then finally you have independent float, which is a measure of the minimum available time over the activity duration. Okay. Now, this is based on the assumption that preceding activity finishes as late as possible and succeeding activity starts as earlier as possible. So, for that, we are defining the independent float. Okay. Followed by this particular problem now. Okay. I'm sure you should be, thorough with this problem. But as I said, I shall be uploading a different videos for discussing the problems. Okay, so please don't worry about this. Okay, you shall soon see a video where I will be explaining the numerical problems. Okay, now we have this concept critical activity and critical path. Okay, now critical activities are those activities which have got total float as zero. Okay, we have already seen how we calculate the total float. So for any activity, if we get the total float as zero, then that activity is known as critical activity. Okay, so the points to be noted over here are like the EST value would be same as LST, and also EFT would be same as LFT. Okay, for a for general reminder, EST is earliest start time, EFT is earliest finish time, LST is latest start time, and LFT is latest finish time. Okay, so the time available and the required activity duration are same. Okay, for critical activities. So in case critical activities are delayed, then the entire project gets delayed. So that's why they are known as critical. Okay, then you have critical path, which is nothing but the path joining all the critical activities in a network. Okay, in short, it's known as CP. It is generally the longest path of the network, and time along this path will define the completion time of the project. Okay, so that is also very important. We determine critical path by calculating the total float with respect to all activities. Okay, we will check all those activities which have got zero total float, and when we link up these, when we join all those activities having zero total float, we would be getting the critical path. Okay, and a network may have more than one critical path. Okay, please make a note of this factor as well. Okay, then you have a problem on critical path. Okay, then we come across this topic known as work breakdown structure. Okay, so work breakdown structure in short is known as WBS. Okay, so this technique is used to establish the hierarchical order in a system by breaking the project into recognized systems, so and discrete activities. So any big activity, for example, guys, if you are going for construction of a building, okay, now you can't, ideally imagine the whole building, coming up, appearing in front of your eyes. Okay, it doesn't happen like that. So when you're going for construction, okay, you need to be going step by step. So in order to, make things simpler, we, try to, break down the whole work into smaller components. Okay, so for example, now we have a compound wall, and that can be broken down, okay, as these activities. So you need to go for excavation, then masonry and foundation, which is again having two other activities, the related ones, concrete and foundation and damp proof course, then masonry and superstructure, okay, pointing, coping. So all these are activities which are coming under the construction of compound wall. So this is a work breakdown structure. Okay, so this is again, then we have this explanation of work breakdown structure. See, work breakdown structure also has appeared in short answer type of question, okay, carrying 2 marks. But we never know, okay, you might expect it as either A bit or B bit for any of the long answer question. In that case, it could carry as much as 7 marks as well. But the probability of this question appearing for 7 marks or 8 marks is very, very less, okay, because I think, in my opinion, it can go for a 5 marks answer only. Okay. So we have this scheduling, okay, which is nothing but the process of fitting the work plan to a time frame. Okay, it indicates the start or completion of the activity. Okay, then we have another representation known as bar chart. Okay, in bar chart, we are, this is also known as Gantt chart, after Henry Gantt, who had developed this technique around 1900. Okay, so here basically we are using two coordinate axes, x and y, and one axis shows the time. Okay, the other axis shows the job or activities. Okay, and the length of the bar, okay, it identifies, it shows the duration of the activity. Okay, and in some project the jobs may be taken up concurrently, that is all together, and sometimes one job should get completed so that the other job gets started. Okay, so in the bar chart, some of the bars are parallel to each other. Okay, those parallel bars represent concurrent activities. Okay, some run serially, like one bar beginning after the other bar ending, and the level of the detail of activities would be shown. Okay, so this is one example of a bar chart. Okay, this is an example of bar chart, how different activities have been shown there. We can also see the bars which are representing the durations. Okay, now bar charts have got certain limitations, certain disadvantages also. Okay, now here bar chart will not show the relationship between all the activities. Okay, then moreover, it cannot be used as efficient control device. Okay, so it doesn't show the progress of each of the activities, okay, that is happening in the project. The bar chart will doesn't show the quantities of work, okay, like for example how much work has been completed, okay, how much what is the sft of brickwork which has been completed. Now that can't be shown in a bar chart. Then critical activities, doesn't identify critical activities. Okay, it does also doesn't show the critical activities here. Okay, the horizontal lines can be juggled to fit within the specific or compressed period. Okay, so that is another disadvantage. Then we have this differences between PERT and CPM. Okay, PERT is a network technique which stands for program evaluation and review technique, and CPM stands for critical path method. Okay, so the differences, okay, have this question has appeared many number of times. Okay, please make sure that you are learning the differences between PERT and CPM. Okay, so it's very simple here. PERT is generally event oriented, CPM is activity oriented. Okay, and in PERT, that is in program evaluation review technique, we are using three time estimates. Okay, one is known as the optimistic, followed by pessimistic, and most likely time. But whereas in critical path method, we have a single time estimate. Okay, which is being used for the different activities. Now, PERT is generally used for pioneering type of projects. Now, pioneering we mean those projects which are totally innovative, which haven't been done in the recent past. Okay, so there we don't have any prior knowledge or data about the different activity times. But CPM is generally used for repetitive types of projects. Okay, those projects which have been constructed, which have been accomplished in the near past, and the contractor has a fairly good idea about the duration of the project and duration of the different activities. Now, PERT lays emphasis on project construction time without cost constraint. Yeah, this is about the PERT. Okay, but whereas in CPM there is an emphasis on both time and cost. Okay, optimum usage of the resources and then minimization of overall project cost. Okay, so in PERT we have a formula for expected time TE, which is equal to T naught plus 4 times TE or TM plus TP whole divided by 6. TO is the optimistic time. Okay. T here we should have be having TL, I think most likely time, and then TP is the pessimistic time whole divided by 6. Okay. So we have another technique which is known as milestone chart, where we are representing the activities. Again, here milestones or key events, they are represented by bars. Okay, all main activities are divided into number of sub activities, and we can monitor which activities are lagging behind and how we can speed up the activities. Okay, and we have lots of milestones in the milestone chart. Okay, that milestone chart can be seen over here. Okay, this one. And for program evaluation and review technique, okay, we have some introduction part. Okay, it was developed by the engineers of the United States, right? Here we are having three time estimates, and okay, optimistic time estimate, pessimistic time estimate, and the most likely time estimate. Okay, so you have the formula to calculate the expected time, right? So see here, the basic difference between the problem of PERT and CPM is that in case of PERT, program evaluation and review technique, you need to find out the expected time using the formula. Okay, you are already having data about T naught, TL, and TP. Okay, but in CPM you have the single time estimate which can be used. Okay, so once you get the expected time in case of PERT, then the remaining problem is same as the critical path method problem. Okay, so you can just go to this problem then. Okay, that's it. So see here, basically here I couldn't find this some of the problems here. So you have lots of problems. That is, you have problems in critical path method. You have problems in program evaluation and review technique. So guys, please make sure that you are being thorough with the problems. You cannot take any chances. Please don't think that if you are thorough with the theory part, that should be really easy. No, see, the problems are equally important. Okay, so in unit 2 you can expect one 14 marks problem regarding the construction of CPM, calculation of EST, EFT. Okay, your what do you call total float, free float, independent float. You can get one big long answer question, or you could have part A and part B. Okay, so one problem could be on CPM, another problem could be on PERT. We never know. So this paper will certainly be there will be a numerical problem for unit 2. Okay, and as I have told you, as I have committed, definitely I'll be posting another video where I'll be explaining you the problems on PERT and CPM. Okay, guys, in the class I do remember at least worked out 3 to 4 problems on CPM. Okay, unfortunately we couldn't get more problems on PERT. Okay, but as I told you, once you calculate the expected time in PERT, the rest of the problem is same as the critical path method. Okay, so please make sure that you work hard. Okay, this particular video will serve to revise unit 2. So at the end of this, you should be able to understand all the basic knowledge, basic information which is required for unit 2. Okay, so you can also expect now remaining videos. So that's it for me, and please do leave behind comments. Okay, if you find this useful, please make sure that you recommend my channel to all your friends who are in other colleges as well. Okay, and that's it from me. Have a nice day.